2, 1.
The ICI-4 rocket had a unique job. It was fired into Aurora Borealis, the northern lights, in a bid to answer why loose electrons caused by solar flares interfere with navigation and communication systems.
The sun is constantly bombarding the Earth with a very hot gas, with the solar wind, and that gas is made of electrons and protons. And when that solar wind reaches the Earth, the particles manage to follow the magnetic field lines, and as the magnetic field lines converge towards the poles, these particles will just follow the field lines and get in our atmosphere and collide with the particles in our atmosphere, with the neutrals. These interactions between particles with origins in the sun and origins here will create the Aurora Borealis.
Researchers at the University of Oslo fired ICI-4 into the lights in February. They hope the data will help scientists improve GPS and communication systems and predict space weather. Attached to the rocket was their newly designed 4-needle Langmuir probe, which can take hundreds of times more electronic measurements than other systems.
This is the Langmuir probe, the probe that collects electrons and ions, the free charges in the ionosphere, and from that we can actually understand the structures and processes that are occurring, that are happening in the high latitude ionosphere, in the auroral.
The researchers say the mission was a success, though analysis could take years. With their Langmuir probes now used by both NASA and the European Space Agency, the Oslo team says it's put a rocket under the whole future of space exploration.